Hello everyone, it's October the 11th. Man, it's getting cold. Getting cold, I have to put a sweater on. Alright, a little bit late. Let's see how fast can we do this. Alright, what we have today is divide intervals. Wow, we're still doing intervals. Divide intervals into minimum number of groups. Okay, 2D array, we got a bunch of intervals. Oh, both are inclusive. All right, both are inclusive. You have to divide the intervals into one or more groups such that each interval is in exactly one group, okay? And no two intervals that are in the same group intersect each other. Right? In the minimum number of groups you can find. Yeah, of course, if you just say each interval has its own group, then you solve the problem. But we want to reduce the number of intervals. Two intervals intersect if there is at least one common, and because we are inclusive, so this counts as overlap. Okay, pretty straightforward. What is wanted? Let's see the constraints. 10 to the 5th. All right. In the first one, we have 5, 10, 6, 8. I mean, each one has to be in one. So 5, 10 definitely need to be in one interval, right? So I have 5, 10. And then anything that's overlapping with 5, 10 cannot be in it. So 6, 8 cannot be. So 6, 8 has to be its own group, right? Because it's overlapping. And then 1, 5. 1, 5 is not overlapping this. Oh, are you greedy yet? So we say, okay, 1, 5 is here. And 2, 3. 2, 3 cannot be here, so 2, 3 is here. And then 1, 10. 1, 10 has to be its own. All right. All right, let's sort it out. Let's sort it. You know, usually this type of problem will have a better understanding if we sort it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's sort based on, so we have 1 to 10. Okay, 1 to 10. Yeah, so we basically have 1, 5, 1, 10, 2, 3, 5, 10, and 6, 8. Right. So I have 1, 10, and we have 1 and 5, and then 2 and 3, and then 5 and 10, and 6 to 8. What do you think? What does sort help you? It kind of order it, right? Kind of order it, which means if neighbors share the same, then they must be in different groups. And then when we put in the groups, they are also sorted. So, okay. So this has to be in group 1, 5, right? And then 1, 10, it's the same as the previous group. Right, it's the same as the previous group, so I cannot be in this group, so I have to go group 2, 1, 10, right? And next is 2, right, 2, 3, then we always compare to the end because we are sorted, right? And each one is, we're saying they're guaranteed not be overlapping. So when you come in, if you overlap with this, you overlap the previous. So you just only check the end, right? Check the end. Okay, so it's overlapping with this. It's overlapping with this. So 2, 3 has to be its own. And we can just record like the end, right? The end. Okay, and this end is 3. The next is 5 to 10, right? 5 to 10, and the start is 5. So are you telling me that we need to create a priority queue in which we save the end, and when a new thing come out, we need to find, because if it's big, right? If it's bigger than this, then there gotta be overlap, because it's sorted for the start. So if you have an end that is bigger than your start, and then because it's sorted, so its start must be smaller or equal to you, so that definitely gonna be an overlap, right? And your goal is to put your interval into a group that's just fitting you, right? But with as small as possible. That is a good question. Yeah, what if we have like a 2, 3, we have a 2, 4? Which one you put 5, 10 in? I guess it doesn't matter because you sort it already, right? You sort it already. So it doesn't really matter because you sorted it. Because you sort it. Since you sorted it, then each time the new one comes will always be bigger, right? And what we're trying to do is you know, you find the smallest to put yourself in, because you're also small, right? So you put the smallest in, and that's kind of greedy. I feel like it's a bit greedy, but you probably should prove it. That is, whenever you want to put a new interval in, it has to go in the one that has the smallest, right? It has to have the smallest. And if the smallest doesn't work, then you have to get your own, right? But if the smallest works, you put into there, even though there might be multiple still available. Now the reason being, actually it doesn't really matter, does it? Does it matter? Like you can put in all these. Yeah, it doesn't really matter. Actually, I think anyone will work. Because if you have 3 options, you can put your in, right? Then all the intervals like next to you, like to the right, they can all fit in any one of these as well. So you just need to fit one, right? You just need to fit one. It doesn't really matter. But we do have to sort with, if that's the same, then you have to get the smaller things go smaller, and a smaller ending goes front, so you can kind of packet it. Then if that's the case, why do you use priority queue? Well, I use priority queue to quickly find out what is the smallest, so I can decide whether I need to create a new one or I can just put it in. And in this case, priority queue tell me there's 3, so I can put 5, 10 here, and then I'll update 10 becomes, yeah, so it becomes 5, 10, 10. And next one is 6, 8, so I can put here 6, 8. So in total, I have 3. The runtime will be O1 login. I need to sort it, and then I need to create a priority queue. Yep, I think this shall work. Yeah, priority queue with this one should be good. I don't see any issue with it. So I need to first say arrays.sort. We're going to sort intervals A, B. All right. We say A0 is equal to B0. If it's this equal, then we say integer.compare A1, right, B1. Otherwise, we say Otherwise, we say integer compare a0 and b0. Right, that's kind of our baseline. We sorted it, and then we do priority queue. It's gonna be the int pq new priority queue, and again ab. This one will sort based on compare a0 and b0. Right, and here we need to say it's gonna be the end of the last interval in a group and the group index. That's kind of how it is. Okay, I don't like it to be too long. End of last interval in a group. Okay. All right, and we need the number of groups. Right, int res 0. Okay, I say for int interval of intervals. Right, and then we say start is interval 0, and I'll call it S and E. Interval. Okay, so we have a start and end, right? Then what we're gonna do is to check, right, if pq dot is empty or pq dot peak. No, I think it should be like if pq is because I need to pop. Wait, hold on. We don't pop. If pq is empty or pq dot peak 0, which is the end, if that is larger or equal to start, right? The smallest is larger or equal to start, and everybody is bigger, so this all have overlap. So in that case, we need to say res plus plus and pq dot add new int and new end and the current index. Actually, we can do this, right? Because we have to add a new one, and we have the group index. Cool, that's if that. Else, which means pq is not empty and the top is good, right? Is good. Then int index. Actually, I can say pq dot add new int e. So we need to get, and we don't increment, right? So we need to get it. So the pq dot poll, right? So we poll it and we take its index, right? We take its index and then we put it back in, and yeah, we go this, and at the end we'll return res. Okay, give it a shot, see how it goes. We halfway there. Actually, I think we're full way there. And we're saving time, when saving resources by not actually getting the index, because we don't need the index. We just need a ideal of the index, right? Use first sort intervals by its start, right? Then we use a priority queue to keep track of the end of the last interval in each group, as well as the index of the group. For each new interval encountered, right, we compare the start with the smallest and in the priority queue. If the priority queue is empty, or the smallest and is not smaller than the new start, we can guarantee that the new interval has overlap with all the intervals in the groups. Thus, we create a new group. Otherwise, we put the new interval in the group with the smallest end. In fact, this does not matter, right? That is to say, the new interval can join any group as long as its end, right, is smaller than the new start. However, we are using priority queue, and it is very easy to get the smallest end for among all the groups. One more thing to note is that we don't have to materialize the groups. All we need is the end of the interval and its group's index. Right. All right, let's take a look. Just to make sure we haven't changed anything in the logic. All right, let's see if we pass. And we did. So this pretty much is the correct answer, but the performance is a little bit, I think we have to sort. Maybe we don't need to use a priority queue, maybe. I do not know. Oh, yeah, I don't think you need to. All right, here is the idea. I think we don't need, hold on. Update. I think we don't need to keep track of the index of the group. The number of groups is the size of the priority queue. Thus, all we need is to keep track of the end interval. This is the same, but this we can change it into integer. And this can just compare A, compare B, and then, yeah, we don't need this, right? And then we don't need this either. So we grab this, and we just say if the peak is larger than, you know what? That's also element. How do you say interval? Like interval. Okay. So this is the interval 0, and we'll add interval 1, right? This one we will we'll pop it first. So we'll have PQ, have the pole, and PQ have to, do we have like a PQ dot pull and add? I don't think so. Add, no. Pull, no. Okay, so I pull it first and then we'll add it. ITV1. Look, both do this add. So we just need to decide when we need to pull, right? So we can just say if PQ is not empty and PQ dot peak is smaller than interval 0, then PQ dot pull will pull the smallest, and after we pull it, we will always yeah, because the new one has to add it no matter what. Then it's not a result, it's no result, it's going to be PQ dot size. Okay, let's try this one. Same idea, but I think by not using an array, I think we make priority go faster. Hopefully, at least we don't have to create array every single time. Okay, and fewer lines. Okay, it is faster, but all right, what this means the real performance improvement has to be not using this method. Okay, not using this method. Then what do we do? How do we not use this method? I mean, if you can try tree set, I can see we can do tree set, but that's just the same. I don't think we'll make it even better. Maybe we don't have to sort. No, we have to sort, because you need to guarantee that everybody behind you, like the ones hasn't been processed yet, they all have large or equal front. So yeah, I don't know. Let's take a look. Let's see. Sorting of priority queue. Oh, and login. Oh, line sweep again. Damn. Okay, hold on. Let's see. What is this? Prefix sum. What? What the hell? Prefix sum. I have no clue what they're trying to do. Huh, start with a value +1. That's line sweep. End is an end event at n+1 with a value of -1. We sort the events. Find the prefix sum. Prefix sum. This will track the number of intervals active at any point in time. Traverse the sorted events. For each event, update concurrent intervals by adding the value of the event. Track the maximum value of concurrent intervals as max concurrent intervals, which represent the maximum number of overlapping events. Okay, so we create an event and we add a new. Dear me, okay. And you sort events first by time, then by type. One for start, so if they're the same, you do okay. Concurrent intervals, maximum concurrent intervals. We sweep through the events. Concurrent intervals. Okay, so we just plus minus. So you'll have something overlap, right? Overlap. Maximum, we find a maximum, okay. And then we return maximum concurrent interval. Wait, what? You just return the maximum concurrent interval? Oh, wait, hold on. Wait, really? Uh, oh, that is actually true. Okay, yeah, this is actually okay. It's different, very different from what I was trying to do. But it's good. Basically, it's saying what is the minimum number of groups needed, right? And you can find the minimum number of groups needed by looking at what is the maximum number of overlap. Because if you find the maximum number of overlap, all those overlaps have to be their own group. So you have to split them into their own group. And voila, that's it. So you're finding the maximum overlap. Gotcha. All right, so this is line sweep. Oh, I guess it's the same idea. Line sweep. But you still need to sort, right? Tree map. Got a tree map. Point to count. This plus one. And then you go through. That's exactly the same, you just don't sort it. What's the difference? How about this one? Ooh, k plus n plus k. Well, I think my approach is simpler than them both. All right, my approach is simpler than them both. I might post my approach. All right, so what is this? Oh, you just put it. That is stupid. All right, we can post ours. Main heap. Oh, I think he already posted. Da, 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 da. Yep, that's it. That is the solution. That is the solution. I think we got the same as him. 2022, 2 years ago. All right, that's it. Good problem. Good problem. All right, I'll see you guys tomorrow. Adios.